Assalamualaikum warahmatullahi wabarakatuh and very good day to Dr. Nur Ain binti Ibas and fellow classmate. So my name is Zari Iskandar bin Muhammad Kafizan. My matrix number is CF240195. We are from Group 2 and today we'll be presenting our group project for the subject Engineering Mathematics. The title of our project is Slope of Surface. This topic focuses on how gradient and partial derivative are used to describe the stiffness or rate of change on surface in 3 dimensions. We hope this presentation will help deepen your understanding of this important mathematical concept and its application in engineering. So go to the next slide. Okay, before we begin with our main content, allow us to introduce the member of Group 2. So the first, it's me, Zari Iskandar bin Muhammad Kafizan, with the matrix number CF240195. I will be one of the presenter for this project. So the next, we have Muslimuddin Asfar bin Muhammad, CF240068. Then we have Dia Rahman bin Sudirman, CF240276. Also in our group is Muhammad Aiman Hakim bin Jamaluddin, CF240034, and lastly, Muhammad Khairul bin Hashim, CF240201. Each of us contribute to different part of the project, from research and analysis to slide preparation and final presentation. With that, let's move on the problem statement. So this part I will present about introduction, problem statement. To explore the analysis the factors that determine a surface slope, taking into account the physical and mathematical principle that govern surface inclination, option, and in-depth grasp of the impact of varying slope on the various terrain and building types, with a specific emphasis on real world application and possible issue in environmental science, engineering, and construction. The purpose of this research is to address concern with stability, erosion, and building parasiticality by presenting a true knowledge of the multiple way that difference in surface load influence different domain. We seek to occurring insight that can drive improved surface design and management, decision making by investigating the mathematical and physical element effective slope. The research will give crucial information for decreasing environmental hazard, boosting overall infrastructure resilience in the face of eroding surface slopes, and optimizing construction project. So go to the next part. Okay, for this slide, I will continue presenting about script filler table. So this slide show our filler table, which is we use to guide our project based on the fact, idea, learning issue, and action related to the topic of slope of surface. Let's start with the fact column. We observe a real-world issue where retaining wall behind block 1 failed due to low safety factor. The failure was caused by the combined weight of the building and water pressure. This high and important as understanding slope stability. Next, the idea column in civil engineering, slope stability is a major concern, especially in hillside development and retaining structure. One of the key application of engineering mathematics here is in safety factor analysis. We use a mathematic model to assess whether a slope will remain stable or not under certain condition. Then the learning issue column in mathematics is slope or line and defined as the risk of overrun or the change in y over the change in x. To better understand slope surface, we need to explore topographic analysis, slope equation, and how model slope behavior in practical application. Finally, the action column. We decide to first find real-life example of slope surface. Second, conduct group discussion, and the last, use note and online search to gather more information and support our analysis. So the closing I can say the filler table help used to organize our thought and ensure that our study state focus on connected to real engineering challenges. So that's all from me. I will pass to the next presenter. Thank you.
My name is Muhammad Karim Nashim. I'm going to present about our background study. So basically, the fall of Highland Tower is in 1993, which is killed 48 life. Astro Awan in 2020, December 11, is a terrible example of engineering negligence. The accident was caused by a landslide owing to inadequate drainage and unstable slope. Proper mathematical modeling of slope angles, water flow, and soil pressure might have recognized hazard early and potentially avert the tragedy. This story demonstrates how vital mathematics in civil engineering, especially in assessing topography, anticipating danger, and construction safe building. Tools like contour line analysis, hydrological simulation, and trigonometric surveying let engineers make educate, safety-focused choice. The Highland Tower tragedy served as a wake-up call for integrating rigorous mathematical analysis into early design stage. Without such precaution, even minor oversight can lead to catastrophic failure. Secondly is objective of the study. Firstly is calculate the slope of real-life surface by applying mathematical and topographical analysis. Secondly is to identify the shape of level curve or contour lines, which are essential in understanding terrain, elevation, and guiding safe and effective design in civil engineering project.
My name is Muhammad Aiman Hakim, so show I will show the methodology, which is the formula we are choose is paraboloid. So for the aim is to determine the slope value of a surface. Study in the PFC 25103 engineering math course. So we related this course with the real life, how they connect the mathematical analysis to the real world civil engineering problem. So we focus on the hill slope analysis, what the situation or place I will introduce at the literature review. So we are consider both horizontal and vertical direction to axis terrain inclination. And then the formula is Z equal to A minus X square minus Y square, which is paraboloid. So that's a methodology. My name is Muhammad Aiman Hakim, and I will present about the literature review. So the literature review, we took the popular case in the Malaysia Highland Tower collapse in 1993. So the collapse was one of the Malaysian worst such a disaster. It was caused by a landslide behind Block 1. The landslide happened due to unstable slope condition. Main cause of the slope failure, extended water saturation of the soil due to heavy rain, poor drainage system which is failed to divert water, weak retaining wall design that hold the soil in place. This issue made the soil lose strength, leading to landslide. Importance of engineering mathematics is slope surface analysis using the mathematical model called predicted the danger yearly. And then this show how engineering math is important to forecast and prevent such a disaster.
Assalamualaikum warahmatullahi wabarakatuh. My name is Diaur Rahman Musriman with matric number CF240276. So in this slide, I will present about explain the mathematical reasoning behind how we evaluate slope on a surface using partial derivative. We begin by considering a differentiable function of two variables, fxy, which define a surface in three-dimensional space. This surface could represent something like a hill or terrain, which each point xy on the horizontal plane correspond to a height value fxy. Now imagine we pick a specific point on this surface labeled by x0, y0. At this point, there are infinitely many directions in which we can move, and therefore infinitely many slopes we could compute. However, to simplify, we focus on two specific directions that are easy to analyze. In the x direction, the rate of change or the slope is given by the partial derivative sigma f divided by sigma x. In the y direction, is given by sigma f divided by sigma y. This partial derivative help us understand how the surface rise or fall when we move strictly along the x-axis or y-axis. On the right side on the slide, we have 3D terrain map showing a selected area, likely our real world surface. This image support our justification by linking the mathematical concept to an actual geographic surface that we are analyzing in the project. Alright, we move on the calculation section of our project. This part involves determining the slope of a surface defined by the function f(xy) equal to source of power x power of 2 plus y power of 2, which represent a 3D shape like a smooth hill or dome. Step-by-step calculation. Number 1, point of interest. We are focusing on the point 2, 1, source of power 5, where x equal 2, y equal 1, and f(xy) equal to source of power 2 power of 2 plus 1 power of 2 equal to source of power 5. Number 2, partial derivative. To find the slope of the surface at this point, we calculate the partial derivative in the x direction. Sigma f equal to sigma x. So I will give the answer 2 divided by source of power 5. In the y direction, sigma f divided by sigma y equal to 1 divided by source of power 5. Those two value represent the slope in the x and y direction at the specific point. So number 3, equation of the tangent plane. We use the point slope for a surface. So substituting in, we combine everything in one calculation. Z equal to source of power 5 plus 2 divide by source of power 5 multiplied by x minus 2 plus 1 divided by source of power 5 multiplied by 1 minus 2, not minus 1. Minus 1. This gives us the tangent plane at point 2 and 1. So the critical point calculation on top right, the handwritten portion also explore a critical point analysis where x power of 2 minus 2 3x power of 2 equal to 0. This means we get x equal to 1 divided by source of power 3. The result may relate to checking symmetry or maxima, minima on the surface, useful when modeling terrain behavior or optimizing path. So in 3D graph illustration bottom right, the diagram show a 3D sketch on the surface with axis labeled and the position of the point 2, 1 source of power 5. This help visualize where the slope is being calculated, how the tangent plane touch the surface. So in summary, this calculation gives us the mathematical model for the slope and tangent at a specific point on the surface. It allows us to understand how the terrain behave at the location, which is essential for application like terrain modeling, structural placement, or even signal path prediction.
Assalamualaikum, my name is Muslihuddin. My metric number CF240068. So for this slide, discussion. This research study how steep a hill-shaped surface is at the point 214 using partial derivative. We found that the slope in the x direction and in the y direction is negative. This negative value means the ground is sloping downhill in both directions at that spot. In real life, this shows that building on this area could be dangerous because structure might slide or become unstable due to gravity. Our 3D drawing shows that the surface meets the x-axis at about 1.29 unit and the y-axis at about 1.11 units. For the conclusion, this study shows how important engineering mathematics is for checking the slope of surface, especially hill-like terrain in civil engineering project. By using partial derivative, we found the slope value at a specific point on a model surface. The results show negative slopes in both the x and y direction, meaning the surface slope downward both ways. This indicates that in real life, such a slope could be dangerous because it increase the risk of landslide or structural instability. That's all from me.